Hello and welcome to NOV Live. I'm Michael Gaines, host of the podcast NOV Today, and glad you're joining us for today's conversation as we jump into the world of PDC drill bit technology and really focusing on some innovative cutter technology today with our guest. So it should be a really great conversation and looking forward to having you be a part. Before we jump into our conversation, we're going to pull in Shelby Dumaine, who manages social media for NOV, and she's going to give us a quick rundown as how you can be a part of our conversation today. Hey, Shelby, good to see you.
Hey, Michael, it's great to see you as well. So today, while we're live here on the show, the great thing about being live is that we can take you, the audience at home, we can take your questions throughout the show. So if you have a question at any point for our expert on the show today, you can comment it in the comment section below. Whether you're on Facebook, LinkedIn, or YouTube, I am live in the comments. So I will see all of those as they come in, and we are going to get to as many questions and comments as we can during the show. Speaking of questions and comments, we have our first segment today, which is the Rig Geeks Post of the Week.
Rig Geeks Post of the Week.
So I know it's been a while since we've done Rig Geek Post of the Week with NOV Live International last week. But to remind those who are maybe new to the show or it's been a few weeks, Rig Geek Post of the Week is where I ask a trivia question, something about the industry or some technology, maybe something to do with the show that we're doing today. And we're going to pull up a photo, ask a question, and then at the end of the show, we're going to reveal the answer. So throughout the show, if you think you know the answer to the trivia question, you can comment that below as well. And we're going to see if any rig geeks out there can play the game and win. If we could pull up the picture for this week. So since we're talking about cutter technology and a little bit about Reed Hycalog here in a minute, the question for this week is, what year did Reed Hycalog run its first fixed cutter PDC drill bit? And there's the question on the screen right there. So we have this photo. It's a throwback picture. And if you want bonus points, can you name the gentleman in the photo? It's the engineer and the the designer and the engineering manager. So the main question is, in what year did Reed Hycalog run its first fixed cutter PDC drill bit? And for bonus points, can you name the gentleman in the photo? All right, stay tuned, and then at the end of the show, we will reveal those answers. All right, Michael, back to you.
All right, thanks, Shelby. Sounds good. Well, as Shelby mentioned, we are talking about technology from NOV's Reed Hycalog business unit, and specifically talking about cutter technology. And to help us understand that, we have the pleasure of talking with Tom Roberts, who is the Vice President of PDC Strategy and Development, joining us from Conroe, Texas. So, Tom, thanks for joining us today.
Yeah, thanks, Michael. It's great to be here.
So maybe before we dive in, I know that, with drill bits and cutter technology and everything that goes into it, there's been, everyone's kind of in the same boat and facing some of the challenges in the market that's been a result of some of the market conditions and COVID as well. So could you talk about maybe some of the challenges and how you all are facing that?
Yeah, absolutely. I guess that's a very good question to start with. One thing I would say, though, is that really our plan is to remain focused on our strategy, and that's designing and improving better product for applications for our customers around the world. So it's true we have to do more with less today, but now more than ever, it's very important that we have improved performance for our customers. So everyone is looking to lower costs today, and what better way to do that by applying state-of-the-art, efficient cutter technologies so that they can drill their well more efficiently, faster, and TD the section. So this is why these these cutters and the drill bits that we provide from Reed Hyclog are really important for the operator to provide valuable for their applications.
Right. So let's maybe we can stay on this topic because I know, and I had the pleasure of actually starting my oilfield career in Reed Hyclog right down the hall from you. So it's some good memories. Yeah. Hopefully I did an okay job. But one of the things I wanted to talk to was talking about the idea of the advancements that we're having in Ion and Ion Plus. Can you talk about that?
Yeah, sure. Well, basically Ion was our step towards designing application-specific cutters for the applications globally. So we have a wide range of cutters, whether they're cutters that fail from that need greater abrasion resistance or thermal resistance or toughness, impact, strength, etc. So we have a group of engineers that are focusing daily on developing improvements for any given application. So we do the forensics, and we're trying to figure out how can we overcome those performance limiters in any given application. This chart here for Ion just shows over the last 8 years a huge improvement in performance. You can see as each grade is being, this is just really a fraction of the many grades that we have in our portfolio today. And we've had, as shown here, a 300% increase in abrasion resistance through to 2020. So more than ever, we have some great product coming through. In fact, we've beaten the 2020 is already split between many different grades and have improved performance than shown on this chart. So this is really a large focus of our group, providing and our understanding of how different rock formations fail cutters. And really, we're applying that, getting the exact right grade to overcome those performance limiters. And then more recently, we've been applying this to shape cutters such as the Ion 3D.
So for those that just joined us, we're talking with Tom Roberts, who is the Vice President of PDC Strategy and Development with Reed Hyclog. And we're talking about advancements in cutter technology and specifically how that applies in today's market. So if you have questions for Tom as our conversation unfolds, feel free to put those in the comments section, whether you're watching on Facebook, YouTube, or LinkedIn, and we will get to those questions in just a little bit as those questions come in. So glad you're joining us, and feel free to join and jump into the conversation. So Tom, I wanted to maybe touch on a point you made just a moment ago, and you had that graphic that showed the advancements of the cutter technology, and candidly, I think it's really good. But I think people at the end of the day want to say, great, but how has that really benefited folks in the real world, so to speak? So can you talk a little bit about that?
Yeah, sure. There's several. I mean, basically, we've had breakthroughs in global applications, and our team look after Eastern Hemisphere, Western Hemisphere. I guess closer to home in Texas, for West Texas, one I can talk about is it's a very tough application where you have to drill through interbedded formations, particularly in the vertical and lower vertical. It gets very difficult and challenging. There we were experiencing breakage on the tougher grades that we'd prepared for that application. With detailed forensics, we're able to really look to a high level to understand what was causing that failure. And what we found in that instance was actually the carbide substrate supporting the diamond was suffering from corrosion and then erosion. And we developed a more improved grade with improved corrosion erosion resistant carbide and applied a tougher diamond grade to that. And that today is just doing fantastic. It's doing really well. It made all the difference. And again, this is where our customers were able to benefit and avoid, bits being damaged beyond repair and being able to complete the section. So that's just one example. And then the other one is, I guess, the Ion 3D over the last 2 or 3 years has just taken off globally. It's just done so well. It's a new shape that we've introduced. And what's really important, though, is to make sure that we have the exact right grade that's specific to the application, and then combine that with Ion 3D, which is our new flagship cutter for that.
Yeah, so I mean, so the Ion 3D, it's actually something that I was able to talk to some of the team about a while back. But in hearing a lot about the Ion 3D, the shape cutters, I wanted to maybe talk about that as well. So what are some of the key technologies that customers can look to take advantage of, and maybe within that, what are some of the things that you're seeing that's working well in incorporating that particular approach?
So Ion 3D is a way that we've been able to develop a shape that better fails the rock. And if you see in the picture here, what we're looking at here, with a standard full round cutter, which is what we're all used to in the industry, we can develop grades, as I've said earlier, that'll be more efficient and avoid wear mechanisms and breakage. But what happens is, what we've done is we've looked at how better to fail the rock and how to do it more efficiently. If we see the picture on the right, the cracks that are produced into the rock, and by the way, this is the actual scan of the rock following drilling that rock in our drilling laboratory. We see that the cracks go through the rock, so a lot of energy is wasted as we shear through in the shearing direction. With the Ion 3D, what we have now is a way of point loading the rock, and you can see how the scan image on the right, the cracks propagate to the surface more easily. And what this does is we get much more compacted, dense formation chips and more efficient removal of the rock as we're drilling. So this is basically applying this to a point loading, and this shape is what's really working extremely well. Now in the laboratory, we saw a 20% increase in ROP. In the field, we get that and more, and it's been a massive breakthrough. And we're trying this in formations all over the world, whether that's sandstones, but particularly applicable to carbonate formations such as limestones. So this is where it's working well. We have various configurations. We have one which I think was mentioned last week by Bob, which is the saber tooth. And that's where we have a mixture of full rounds and 3Ds to spread out the point loading and also get the best of both worlds. So that's working extremely well. But various configurations of this, and like I say, what's really impressive is how tough these cutters are to complete the section.
Mm. So it's interesting you talk about the advantages and what's working, and so it seems like the full rounds are actually faster and more. The 3Ds actually held up faster than the full rounds. So it makes me want to know about additional developments that you've had, and maybe specifically, how those developments are working for customers.
Well, I guess more recently, although we've had such great success with the 3D, there have been people that have questioned that how can applying a shape to point load the rock be more tougher from the cutter itself? How can it be stronger than a full round cutter? And so what we decided to do is look at the strongest, hardest rocks that we can drill in the lab to really prove the point. We'd seen it already in the field, but we really needed to show our customers how tough and how strong these cutters were. So we went to work initially testing on the Sierra white granite. We used that a lot for our wear mechanism tests, for both thermal and abrasion. And that's the picture on the left there. And then if you get the picture on the right is the quartzite. Now with the quartzite, you can see it's very rugged and tough, and actually reaches compressive strengths of above 50,000 confined strength there, PSI. And you can see that the reason that's rugged, by the way, instead of a nice neat block you see on the left, is because they have to use explosions to break that out. It's extremely tough, hard rock. But the results surprised even ourselves. The goal here was we were going to drill on each rock at 20,000 and 30,000 pounds weight with a 6-bladed test bit. And the only change was that we were going to put full rounds in one, and then exactly the same bit, but with the Ion 3D applied to the other. So what was interesting, if we look at the results on the Sierra white granite, we found that we were able, as we increased the weight, we were able to spool and break the round cutters, and you can see this in the pictures in the top right, left and right there. So the diamond was able to break, but what happened with the 3D is we didn't get a breakage. In fact, we were, once we broke the full rounds at 20,000 pounds weight, we weren't able to go any further with the test. But the 3D survived that, and then we upped that to 30,000 pounds, and we were still unable to break them. So this was really a great piece of evidence for us to show that the failure mechanisms are not just faster, providing less torque, but they were able to better fail the rock rather than the rock fail the cutters as it did with the full rounds. We went one step further and then drilled on quartzite. I think say this quartzite is extremely has a extremely hard rock, 64,000 KSI in strength. And once again, we were able to break the full rounds at 20,000 pounds. But when we went to the 3D, still no breakage. We did get some thumbnail cracks, as we call it. So it's on its limit once we applied 30,000 pounds. So we were able to go much higher on the weight. But a great result to show how tough this shape is. Now, just to finish on that, we have published an SPE paper, and that was given at the Galveston SPE in March, just before this lockdown. It was probably the last SPE show with people in attendance early March, and we presented our findings there and worked with ExxonMobil on a joint paper there. So there was a lot more work. So if those are interested, we can supply the SPE paper for those to look at.
Yeah, no, I think that'll be good. And for those that just joined us, we're talking to Tom Roberts, who's the Vice President of PDC Strategy and Development with Reed Hycalog, and we're talking about the ion PDC cutter technology, breakthroughs, and additional insights into that space. So we're going to continue our conversation, Tom, but it looks like we actually have several folks that are watching now that have some questions that we want to try to get to before we continue on. So I'm going to bring in Shelby Dumaine to see if we can get some of those questions answered by the Tom Roberts. I don't know any other Tom Roberts, so you're just the Tom Roberts to me.
All right, I'll do my best.
Yeah. Okay.
All right. So this first question comes from LinkedIn. Can you talk a little bit about where the ion cutters are being tested?
Yeah, sure. Basically, in all applications globally, ion is our flagship, our best cutter technology. We are getting close to launching Ion Plus. We've started to field test that. This is an enhanced grade, thicker, denser, stronger diamond grades with ultimate leach profiles, deeper with side leach than ever before. But we're trying these globally. In pretty much all Reed Hycalog drill bits are going to have this technology now. So in any challenging applications, whether that's in the Middle East, whether it's Norway, whether it's North America or Latin America, we're applying this technology. So it's working extremely well across all rock types. So yeah, it's pretty much it's a big success story for us.
Mm-hmm. Great. So another question also coming from LinkedIn. Sandra is wondering, how do these work in reservoirs with oil-based mud?
They work with oil-based mud or water-based mud. Not a problem either way. We get adequate cooling as long as we get adequate cooling with efficient hydraulics. No issues at all in oil-based mud. So not a problem.
Great. So for this next question, I know we can't reveal the secret recipes, the secret sauce, so to speak, but Margarita, also on LinkedIn, was wondering if you could talk a little bit about the materials used to prevent or reduce corrosion.
Yeah, that's a difficult one for us to go into. Like you say, we've got to keep the intellectual property, close to chest. But basically, there we understood the problem. That was the first issue, where we had to do a lot of forensics and high-level investigation to figure out why the diamond was chipping and breaking. And we realized that the erosion and corrosion was so bad at the back, almost immediately behind the diamond table, that this is where the diamond table was chipping and breaking once it hit the harder rock interbedded formations. So really all we've done there was you can't just change out put an erosion corrosion substrate on there and then expect the whole diamond cutter to sinter and have the same properties. So there's a lot of art involved in science to ensure that you create a tough, strong, strengthened diamond with that more corrosion resistant carbide that's applied. But I can't go into too much more detail than that. But that's basically why it worked.
Yeah, I won't twist your arm any further. I know that's probably as far as you want to go, so that's no problem. But thank you for the insight. That's helpful. So when we maybe when we talk about the Ion 4D, can you unpack that for some folks to say, okay, maybe they're familiar with the Ion range of cutters and maybe kind of understand other approaches, but with the Ion 4D range, can you talk about why is that more efficient, and can you talk maybe about that and how it's performing in the field as well?
Yeah, that's a good point. And by the way, I reached out to one of our customers to let them know we were working on this for today, to have this live discussion. And one of the points, I guess, is a good lead in here is he said that even though we had such breaking records with lower torque, faster drilling with the 3Ds, one of the things that Reed Hyclog did was to go one step further, and this is where the 4D came in. So in our approach, like I say, we're relentlessly trying to come up with more improved geometries. And years ago, this was not possible, right? Because manufacturing technology such as either forming the diamond or using lasers to precision shape the geometry without harming the properties of the diamond. This is why this really works. So what we have here is a family of the 4D, which has full rounds with laser shaped front to apply a point loading in the shearing direction, or a plow effect, if you like. And that's what we have there, as well as a relieved angle on the lower side where hydraulics are able to curve the formation chip being created away from the cutter face. And this provides a lower torque, more efficient cutting action. And then furthermore, we've then applied the 3D chisel to the side of the 4D cutter, which is the 4DC, and the 4DXE, which is an extended, tougher version. And this way we get the best of both worlds. Now we're getting the plow effect or point loading effect in the shearing direction as we cut through the rock, but we've also got the indentation point loading in the actual weight and bit direction. So we get a product that's able to drill extremely fast. And then the only way this can all work is, of course, is if we have the exact right grade that's being formulated for the given application. So that's what we see here from left to right is the 4D to the 4DXC, which is our one of our fastest cutters, I would say, to date. And these are outperforming the 3Ds and give another boost in ROP performance for our customers while providing less torque.
This is really insightful. I glanced over at some of the comments on LinkedIn. Jim said NOV University. Thanks for sharing, because this is really, I mean, and to that point, I mean, there's a lot of insight and technology and teamwork that's going into developing these cutters and really advancements that we're talking about. One quick follow-up before I move on. I wanted to see if you could talk about how you're leveraging NOV's Research and Development Technology Center in addition to other testing facilities to help validate and test some of these breakthroughs that we're having.
Yeah, so we have the rig at Navasota, which is the full rig where we can test full bits, but we also have a drilling laboratory at Conroe as well. And so we can test all of our downhole tools here. Our drilling rig is a state-of-the-art facility, as well as all the the downhole optimization, whether we're running a wire drill pipe, downhole black box recorders and various instrumentation to ensure that we're drilling well. So all of our downhole tools, whether it's agitator or motors, everything can be, as well as drill bits, can be tested at this facility. But here at Conroe, we also have the drilling lab, and this is what we have a new single cutter test a pressure chamber, which we can talk about. We also have the drilling lab as well. It's where we can do full scale bit tests.
No, that's good. So, you know, you've been talking a lot and focusing on the efficiency and drilling for customers. What about the more difficult applications that suffer maybe more historically from impact breakage? Do you have anything kind of on the horizon that you're looking to maybe solve in that space?
We do. We're working towards what we're calling the Ion 5D, which is going to be for tougher applications. This is actually the first time that we've actually come up with something that actually is not necessarily designed for efficiency, but it's designed to withstand really large impacts down whilst it's going through various drilling rock formations, interbedded hard rocks, for example. But I would like to talk a little bit more about the 4D cutter and show some of the videos of the testing from our pre-cut, which will actually help us understand how the rocks fail. Is that something that we could discuss?
I think we've got a graphic that we'll put up in a moment that can help show that. Okay, yep, here we go.
Yeah, this is it. So this is what we're looking at here is inside our pressure chamber. And on the left, you can see very large ribbons being cut. And what's really fascinating for me here is that when we think about a sandstone, if you look how the 4D is on the right, and you can see here how the much thinner ribbons are being generated. And like I say, we're recording all the forces, we're recording the torque response of these cutters. And then we do these single cutter tests, measure all this, and then we also do the full scale bit test. If we take another look now, we can see what this looks like from the side view. This is a pressure chamber. Again, what we're looking at is a sandstone. This is a Tory Buff sandstone with inside a mineral oil under pressure. We can go up to 10,000 psi to simulate the downhole conditions of our drill bits. And what's surprising is when you think about a sandstone, you think about it powdering away. But here, under pressure, you do get formation chips. The picture on the left is a conventional planar flat cutter, and you can see how the cutter is loaded up as the formation chip slides up. So it's creating friction there, it's creating loading, and this is multiplied by the many cutters on a drill bit. But then when we look at the 4D, look how it curves away. The formation is curling away from the face. What that does is it lowers the torque, so we get the same, we get improved drilling efficiency. You can see it closer to the end here, how the rock is curling away off the face of the diamond. So this is what our engineers are working on, understanding how to fail the rock, obviously having the right grade for durability, but also understanding how we can improve our efficiency. And having a lower torque is really important for the bottom hole assembly, whether you're on a motor or rotary steerable. Holding tool face for a directional response, all of these things, having a lower torque is very important for our customers.
Yeah, that was a really interesting graphic, and it's really good also to know, to your point earlier, that you have the facilities and capabilities to really hone in and not only observe but measure all of those forces and effects in order to produce the cutter technology that we have now. So
it's giving us a great insight, and it's good for our customers to see this. Like I say, we're training our engineers all over the world with this technology and bringing this to the customers.
Yeah. All right. Well, we're going to go ahead and transition into trying to get in as many questions as we can. I know we've actually got several that are lined up. So for those that if we don't get to your question, we'll give you a way to get your question directly into Tom in after the program. But Shelby, we'll go ahead and and try to get in a few questions and see if we can't get those answered for folks.
Sounds good, Michael. So I do also want to mention we have a few NOV representatives in the comments right now who are also helping answer questions. So if we, like Michael said, if we don't get to your question in this time, we will get it answered as much as possible. So we have this next one comes from RD Morrison on LinkedIn, and it's a bit of a long one, so excuse me, I'm going to read a little bit.
Okay.
Are you still able to leach shaped cutters to the same depths as standard cylinder cutters? He says, in other words, are 3D and 4D cutters as thermally stable as your best standard cylinder cutters?
That's a great question. And hi, RD. I know RD well, so it's good to hear from you. Yes, well, that's a great question. So typically leaching can be done and the shaping can be done at the end, but we don't want to go into too much detail on that. But I will say that we do test for thermal stability on both full round cutters and shaped 3D and 4D, etc. And we ensure that we have exactly the same, if not better, thermal resistance applied to the particularly the cutting tip, the cutting edge that's drilling through the rock. So that's all part of our testing environment, and we have all those results to fall back on. So great question, though. You would not want to sacrifice thermal resistance. So leaching technology is absolutely applied to both shaped and full round cutters.
Mm-hmm. All right, and we have another question from Xavier on LinkedIn. He was wondering how much less WB or weight on bit is required to fail the rock compared to round cutters.
Another great question. It's difficult for me to recall on that. I know that we get faster ROP with a shaped cutter compared to the full round. So if we see a sometimes 20 or 50% increase in ROP with that, particularly in the lab, we've certainly seen those areas. It's fair to say that if we were to lower the weight of a shaped cutter to match the ROP of a full round, therefore we would need less weight, right? If that makes sense. So it's fair to say that you would definitely need less weight. So certainly great for applications where it's difficult to get weight to the drill bit, maybe laterals, but difficult to, we can get a precise number. I just don't have that immediately to hand, and it all depends on the rock type that we're drilling. But absolutely, the same as we're getting an increase in ROP for a given weight, then therefore it makes sense that it will drill at the same ROP with far less weight.
Good. Well, this has been really good, Tom. I know we're about to move into our next segment of the show, but for those that want additional information on the ion-shaped cutters or really any of the solutions and technologies with Reed Hycalog, I think the easiest way for them is to maybe send you an email. Is that right? Yeah.
My email is tom.roberts@nov.com. So I'd be more than happy to take any emails that come my way. But and if I really, perhaps I can forward that to the right person within the country that you're working. So, but more than happy to set up presentations for our customers as well. So let us know how we can help. We're here to help, and that's what like I said at the beginning of the call. If we can save the customer money by providing greater efficiency, that's what we're trying to do.
Excellent. All right. Yeah. Well, we'll definitely make sure to have that. And in addition, if you'd like to view at your own leisure on the NOV website, we'll put that URL on the screen as well, and we'll be sure to put that in the LinkedIn post, and try to put that in the comments as well for those of you that would like to check out the Ion series of cutters or any of the other drill bit technology that NOV has to offer. So thanks, Tom. Been good talking with you, and appreciate your insight.
Yeah, thank you, Michael. It's been great. I enjoyed it. Thank you.
So we're now going to move on to our next segment, which is called the Ask Assaad segment. All right. So each week we're going to be having NOV's Director of Business Strategy, Assaad Mahana, to join us to give us some insight on the market and other strategic insights from the business standpoint. So Assaad, good to see you.
Good to see you too, Michael.
So from maybe a macro standpoint, it doesn't take hardly any effort at all to know what's been going on in the overall industry and the market forces that have been at play. But I think it's also helpful to look at it from a historical standpoint. And I know that you've been spending a good deal of time doing that.
Yeah, let me start with what we've had in the last couple of weeks, Michael. I think since we saw the WTI drop in the negative about 3 weeks ago now, WTI jumped back into the 20s, closer to $25 today, with some good news along the way. We're also, for maybe the first time in years, we saw stocks, the energy companies' equity prices go up faster than WTI, which shows some healthy indications. And remember, we've seen a few companies go over their earnings call in the last few weeks. In terms of oil production, or really cuts of production, the U.S., we talked about curtailment in the U.S. I think the U.S. is reaching about 1 million barrels per day curtailment. That drops the close to 13 million to almost a little less than 12 million barrels per day coming from the U.S. And at the same time, what we've seen in the Middle East is on top of what OPEC had committed to in terms of production cuts. They're going even further and taking individual initiatives like Saudi Arabia and Kuwait to slash further than what they promised, which is another good indication. It's unfortunately not quite yet enough to balance supply with the demand. The fact that people are not spending, the consumption is not back yet, which means it'll take a little bit more to get back to our original levels.
Okay. So if someone were, kind of looking at this, I know that there are some key historical markers, or at least indicators to reference when looking at the energy markets and kind of how we sort of got to where we are. How do you view that?
Yeah, so Michael, you and I talked to Lauren Singletary a few weeks ago and talked about how this compares to the 80s. We also talked with Larry Angle, and I'll mention Lauren Singletary is our Chief Industrial Relations Officer at NOV. Larry Angle's our President for NOV Process and Flow Technologies. And in both, we touched on how does this compare, I think more with Lauren, with what happened in the 80s. And to mention, looking at this graph, how we've had 10 events in the last 50 years that were significant in terms of oil price. In 73, we had the Arab embargo, where prices doubled in just 3 months, from 24 to 56. And note, this is inflation-adjusted prices. So back then, it was probably $6 or $7. In 79, we had the Iranian Revolution, with prices doubling in just 10 months. In 86, there was an oil crash, and that was what we were comparing with in the 80s. With prices not recovering for almost 5 years after that. Going forward, we saw the Gulf War, a big spike there, and then the Asian economic crisis, which probably could compare slightly to what's going on with prices recovering after 2 years. 2001 with 9/11, we had the attack. With after that, prices shooting all the way into the 165. Remember, this is WTI, dropping back all the way down to $51, where OPEC decided to start with the cuts. Oil jumped again all the way to 2014 when there was another oil collapse, where prices haven't yet ever recovered to. And then 2020 with the price war between Saudi Arabia and Russia, and really shale we're at today. So really looking back, I wanted to bring this up because quite a few things could be pulled from this. First is that the industry is a cyclical and very influenced industry with geopolitical influence. The supply and demand is one thing, but also impacted by many other factors. But with what we can control today, I think there are some instances there that allude to how long this could last. Well, nobody knows how long it lasts, but we know for sure that tightening the belt will need to be at least for next year or so until things pick back up again.
So you mentioned shale, and I know that's certainly been the name of the game for at least in recent years. So how does that play a part? And then and I think maybe a secondary follow up is how do we get to where we're at today?
Yeah. So on that graph we had, you don't have to pull it back up, but we had that pink box on the right, and 2005 to 2000, today, and that's really when shale became a significant player in the production landscape globally, moving from 0 barrels per day in the early 2000s to 9 or 10 million barrels per day of the 100 million that are produced worldwide. So it's a pretty significant jump in 15 years. And that's also the period where we saw volatility of the oil price increase significantly. The resilience and capability of shale companies to adjust and adapt to the various scenarios pushed them to bring down the break-even price lower. Which gets me to really the fundamentals of why we've seen those break-even prices go down. I think the industry attributes 4 factors to why a well cost dropped so significantly from 2010 to 2015. And one thing would certainly be lateral lengths, and that's pushing, getting more of that same well from that same mother bore contributed significantly. Second was the proppant intensity. We pumped a lot more stuff into these wells to increase the frac capability of those wells and get more production. Number of stages was a very significant factor as well, that contributed in getting more out of that longer lateral as well. And then geosteering was the fourth one, being able to place that well very accurately in the reservoir. I'd also add that there are 4 other factors that contributed to this shale boom, but those are more on the well development, the field development side, and those are pad drilling. You had, instead of 1 or 2 wells being drilled on the same well, now you have in some instances north of 20 wells. Well spacing as a result of that became a lot narrower. So one field, instead of having 10 wells, now has 60 wells. Zipper fracking is a fundamental change in how we did frack, which also made drilling cheaper and more efficient. And the last one is contiguity, or closeness of fields. As we've seen over the years, companies coming together and merging their assets and fields, more and more efficiencies were attained, and that break-even price went even lower.
So I know that you're one to always look at the silver lining, and I know that we'll continue to be looking at this space moving ahead. So I think it'll be a good thing to keep an eye on, and look forward to continuing to get your insight and perspective as things unfold.
And on that, Michael, we will be having a conversation with our Chief Sales Officer at Wellbore Technologies, Scott Donald, to talk about how is it that the industry can move forward to make those wells in the shale world even more economical.
Looking forward to that conversation. Been speaking with Assaad Mahana, the Director of Business Strategy at NOV. So Assaad, thanks for the conversation.
Thanks, Michael.
All right, so we are now going to go ahead and wrap up by bringing Shelby Dumaine back in as we give you the answer for the Rig Geeks Post of the Week. And before we show the answer, do you want to put up the original graphic first, Shelby?
Sure. So we'll have the original picture. And as a reminder, we asked the question, what year did Reed Hycalog run its first fixed cutter PDC drill bit? All right. And we actually did get some good guesses. The closest we got was Dan F. on LinkedIn. Well, folks, the answer is, we're going to have the answer pull up. So the year was 1974 on the Isle of Wight. And for the bonus question, I asked you who the gentleman in the photograph were, and that is the designer, John Fuller, there on the left, and on the right is the engineering manager, John Barr. So thank you everybody for participating in the Rig Geek post of the week. We'll be back every week with the same segment. Speaking of next week, we have a really great show. We're going to have Simon Eves. He is the Global Technical Director of Structural Composites, and he's going to be here to talk about subsea composites and structures. So that should be a really great show. I'm excited. That's at 11 a.m. CST next Wednesday, the 20th.
All right. Sounds good. Thanks so much, Shelby. And thank you for joining us today on this segment of NOV Live. If you have any additional questions about what we talked about today, feel free to put it in the comments section, or you can head to NOV.com and select the Contact Us button there, and we'll be glad to get in touch with you as well. So for all of us here at NOV, thanks for joining us, and thanks for listening, and we'll talk to you later.